We are going to see topics in chapter 13, which is the addressing modes. So there are different types of addressing techniques or addressing modes. We are going to see the addressing modes. These are the addressing techniques or addressing modes. Start with the immediate, direct, indirect, register, register indirect, displacement, and also stack. In chapter 12, you already know what is instruction set and how to program using different types of number of addresses. You already learned how to code the instruction in the assembly languages using different number of addresses. For example, 0 address instruction, 1 address instruction, 2 address instruction, and also 3 address instructions. Now in chapter 13, we are going to learn the addressing modes. So what basically the purpose of addressing modes? Basically, it is how to select the operand during program execution. The selection of operand during program execution is depending on the addressing modes. The programmer is flexible to use different types of addressing modes. So there are many of addressing modes here. So the programmer is able to select any of the different types of addressing modes. And by using addressing modes also, we are able to reduce number of bits in addressing field of instruction. So we are going to see one by one the addressing modes. These are the diagrams of the addressing modes. Starts from the immediate until the stack addressing modes. So basically in this diagram, it shows how we want to retrieve or we want to obtain the operand. So we are going to look what does it mean by this abbreviation. So basically A contents of an address field in the instruction. So inside our machine instruction, the instruction format, it is segregated into several fields. And one of the fields, it can be the address field. So basically A, it refer to the memory, while R basically it refer to a register. EA is the actual or effective address of the location containing the reference operand. X in bracket here means that the contents of memory location X or register X. So we are going to see one by one of the addressing modes. The first addressing modes is the immediate addressing modes. So basically this is the instruction format, and this is basically the address field. So the address field basically contains the operand itself. And this immediate is the simplest form of addressing. So I mentioned before this that inside this instruction, the address field basically contains the operand itself. For example, if the instruction is load 100, so means that 100, the numerical 100 is contained inside the address field. 100 is the operand which resides inside the machine instruction as the operand. So the advantage and disadvantage of the immediate addressing modes you can read or you can refer from this slide. We are going to see the next addressing modes, which is the direct addressing modes. For the direct addressing mode, the address field contains the effective address of the operand. So inside this machine instruction, this is what we call as the address field. And inside this address field basically contains the effective address that pointing to the operand. So the effective address is the effective address for the memory, and this effective address basically pointing to the operand. So this is what we call as the direct addressing modes. The next addressing modes is the indirect. So basically inside the machine instruction, the address field will pointing to the memory address. Basically inside the machine instruction, the address field basically contains the memory address which basically contains another memory address that refer to the operand that need to be fetched. I repeat, inside the machine instruction, in the address field, it contains the memory address that refer to another memory address which pointing to the operand that needs to be fetched or obtained. The next one is the register addressing modes. So this one basically different from the previous addressing modes, which basically refer to the registers. So the previous three addressing modes basically refer to the memory, but this one we are going to look into the register addressing modes, which basically pointing to the registers. So address field refers to a register rather than a main memory address. So inside the address field, this one refer to the register, which different to the addressing modes that we learned before this, from the immediate, direct, and also indirect, which basically the address field pointing to the memory, but this one, this address field pointing to the register. And this one basically similar like the direct addressing modes, but inside the direct addressing mode, it refers to the memory, but this one, the address field it basically contains the effective address from the register. So this effective address pointing to the operand that need to be fetched from the registers. The next one is the register indirect. So basically from this diagram, you can see that this the concept is similar like the indirect addressing modes. But the difference is the address field which refer either to a memory location or a register. So for the register indirect, the address field contains the effective address of the registers, which basically has another address of the memory that pointing to the operand that need to be fetched. So this is the register indirect. For the displacement addressing modes, it combines the capabilities of direct addressing and register indirect addressing. Still remember how the direct addressing works. Inside the machine instruction for the direct addressing, it contains the effective address of the memory that pointing to the operand. While indirect addressing, the address field contains the effective address of the register, which basically contains another address of the memory, which pointing to the operand. But now in the displacement, it combines these two addressing modes, the direct addressing and also the register indirect addressing. So the address from the effective address of the register, it will be combined with the effective address for the memory, which basically the combination is the memory address that pointing to the operand. So this is the displacement addressing modes. So these are the techniques inside the displacement. The most common uses are relative addressing, base register addressing, and also indexing technique for the displacement. The last addressing mode is the stack addressing mode, and this one basically is used in the zero address instruction. So for the stack addressing modes, it is a linear array of locations, and it has a push down list or last in first out queue. This one we call it as LIFO. The machine instruction basically not include any memory reference, but implicitly operate on the top of the stack. And this one basically for the stack, it has a pointer which basically pointing to the top of the stack.